So let me cast your mind back to last Thursday, where we were in the sort of 2/3 of the way through the previous lecture. So today, I'm going to try to finish that up very quickly, and then we'll pop over to the next section where you'll find the news of the day and all that stuff. So let me finish up the previous little bit and talk, if you remember, about errors. Now this, I will preface this by saying this and the next two lectures, this previous lecture and the next two lectures are all about the psychology of people using complicated machinery like AI. So one of the things that happens is predictable errors. Predictable errors happen all the time. So Command M, as you probably know in Google Slides, creates a new slide. Command M closes the window and hides it. And if you've got a bunch of windows open, good luck trying to find it. Unless you know about, in Chrome, there's tab search, Command-Shift-A. So that will help you out. So if you don't know that, learn that, because it will save your life. It saves my life constantly. But these are predictable errors. People know that if you put two commands like that next to each other, bad stuff will happen. Now, we were talking about transfer, examples of positive transfer, and I gave the example of the game controllers from different companies. Great, thank you. Or automobiles, putting controls more or less in the same place. Radios, doesn't happen. The power on button is sometimes on the left, sometimes on the right, sometimes you push, sometimes you wave your hands, crazy. But multiple devices don't even have a standard for power on. And so positive transfer almost never works for that. On the other hand, you get positive transfer between different phones. Android and iPhone, they're 90% the same. Yeah, I know there are little differences, but mostly you get positive transfer between that. And record is usually the same. Now, let's talk about transfer when you think about AI systems. So my favorite example of an AI system is Google Search. And so a question might be, if you search for OSLOG, that ring A, I don't know if you can see it, that first letter there is a capital A with a little ring on top of it. Very Scandinavian letter. So ring A. So if you search for that name with the correct spelling of the name OSLOG, you'll get this. Great. If you do it without it, you get something kind of similar. See the differences? It's, well, Wikipedia is still the first one. And so you should start thinking, is this positive transfer, or how should I be thinking as a user of this, thinking about it? If I did double quote ring A OSLOG, which gives me exactly that, I get really different kinds of results. Wow, interesting. Okay, so here now, what I'm trying to show you is that if you do the circle drifted, sorry about that. If I do a search, Command F, Control F, for ring A OSLOG, it finds, it pattern matches all of these down here, which don't have the ring A. So are diacritical marks important, yes or no? Sometimes, right? So if you're one of these people who has an umlaut in your name, does it work to search for your name with the umlaut, without the umlaut? It depends is the answer. Negative transfer happens. So here, for example, I've done a search in Google Docs for OSLOG correctly spelled. It matches there, but it doesn't match in Microsoft Word. That's negative transfer. So see my point? Here's another easier example. Here in the back panel, in Google Drive, I've done a search for owner Jess H type presentation, and it shows, you can see back there, there's actually one result. Interesting, because as you type it, you've seen this before. It's doing hot querying. You see this in Google search and lots of things, where as you type the query, it gives you a partial completion list. So that's what you're seeing here. The 1, 2, 3, 4, 5 potential hits as you're typing. The moment you hit enter, forget it. Forget it. All you get is one. I'm sorry. What? I classified that as a bug, because it can't be that there are 5 partial hits and only 1 actual hit. Okay? I'm going to call this AI because I don't understand what the hell is going on. Here's another example. No, I saw a lot of you in the spreadsheet put Grammarly or spell check, and spell check is another sort of classic AI thing. And so there's a couple of examples here. You see how it does the red underlining? You should be thinking, everybody does red underlining, red curvy underline like that. That's a positive transfer. A misspelled word is like that. The other positive affordance is command or control, click on that thing, and it will offer a respelling list. And so that's what I did here with can't, because C-A-N-T is a legitimate English word, but it's marked as misspelled. Why? It's actually not a misspelling. It's not the right word in context. So this, you may not have even noticed this change. But once upon a time, say 5 years ago, that would have not been spelled, not have been underlined, because spell correction did not take into account context. The words, the same way that there, T-H-Y-R-E is a correct spelling. It's just not the right version of there, right? Cool. So this is contextual. People have added contextually appropriate spell check. The point I'm trying to make is that these things change with time, often in good ways, sometimes in bad ways, sometimes completely unpredictable in ways. So here's Google Photos as of January 2020, not that long ago. I said my cat, and voila, there's my cat. There's my kid, there's my wife, there's my friends, there's my cat in every one of those pictures. Today, what happened? They improved the back end for some definition of improve. So what I'm telling you is that the UX can change depending on which version of the AI you've got. And they don't tell you that. Right? So one of the things we want to think about today and tomorrow and Thursday is how do we think about what a complex AI system does? So in particular, this is Google Maps. This is downtown Zurich, and I want to go from the university over here, University of Zurich, main campus, over here to the Google office on the other side of the rivers by the train station. I do that, it gives me this very nice path. You've all done this, right? What do you know about that path? What do you believe to be true about that path? Is it the fastest? Is it the shortest? Is it the most comfortable? Does it work for people in wheelchairs? Is it the least bumpy? Suppose you've got a bad back and you'd like to say, give me the most smooth path. What's the UX for that? What's the way that you would tell maps that you can do that? What if I want the most scenic route? So here's an interesting thing about maps, is that you all have a mental model of maps, right? So here's a piece of, there are two different maps. So Google Maps on the left and OpenStreetMap on the right. And they're showing exactly the same place up on the North Coast. They're very different representations. So the amount of data you can get and the kinds of questions you can ask each of these systems is contingent upon the data it has and how accurate it is and so on. What do you know about what the data each of those systems has? So if you want to follow trails, you want OpenStreetMap, you don't want Google Maps. In this area, in other places it switches because data depends. Here's another case. I was in Boise and I wanted to go to Stanley, Idaho. So the night before, because I'm a clever person, I'm going to check the route. How long will it take me to get from Boise to Stanley? And it says down there, it will take, if you go the obvious blue route, it'll take 2 hours and 40 minutes, right? The other route is 2 hours and 50 minutes, whatever, fine. I get up the next morning and I look at it and it goes, oh, wait a second. 3 hours and 52 minutes? What happened? There's no way for me to find out. There's no introspection AI UI for this. How would you ask? There's no way, in short. I will tell you what happened. I found out later. There's a huge forest fire up there in that part, the upper left part. But there was no way for me to find out. All I could know is that your route is going to take 4 hours. So how do I communicate with this AI? What's my mental model for this? You've probably seen this happen. You're using Gmail, You're writing a message to a friend like I did, and it pops up a message that says, hey, it looks like you forgot to attach a file. Does this happen to you? I've had lots of people say, oh man, Google AI is so awesome. It tells me if I forgot a file. You want to know how it really works? There's a little regular expression that says, is the word attached in this document? That's it. There's nothing clever about it. I mean, it looks really smart. But my point is, people impute intelligence even to simple behaviors when they don't know what's going on. It's just text search. So let me ask you this question. Here are two different UIs, the UI A and UI B. Knowing what you know about how people think about their AI systems, which one would you prefer? Take a look at them for a second. This is a running app on your phone. This is in today's reading, so people, if you've read the answer already, don't say anything. Okay? How many prefer the one on the left? Raise your hand. Okay. How many people prefer the one on the right? Raise your hand. Okay. This is like 90 to 10 difference. Okay. People clearly like the one on the left. Why do people like the one on the left? Say what you think. It's say again. Oh, you're looking at the stars. You're a star believer. Okay. Anybody else? Yeah. Right. So more of a user focus on the one on the left. The one on the right talks a lot about the technology, right? And if I was going to make a recommendation, stars are cool, no problem with stars, but I agree. This one on the left is more human. This whole class is about humanity. Oh, the humanity, right? So what we're trying to get you to think about is how can we connect our tech with people's understanding? So in this case, if you're a runner and you get this kind of thing and it says the only intelligent running app is a deep neural net, I don't care. I don't care. So the mental model of the system is all the stuff we tell you, all the stuff the designers and system builders tell you, plus your experience with that. So try to focus on the salient human aspects. Tell us things that we can use. Okay, second choice. Which of these UIs is better? Now I've given you a kind of a sampler. The left one or the right one? Left one or the right one? Okay, how about vote for the left? Okay, there's a couple. 1, 2, 3, 4, 5. Oh man, I keep counting. I get more. 6 going once. Okay, one on the right. Okay. Okay, it's a bit a little better. It's more 80-20 split. Okay. Okay, what I would say is the one on the left, because this encourages experimentation and reassures users that experimenting won't mess up their future experiences. This brings up a whole topic, which I think we will get to on Thursday, which is one of the interesting properties of AI systems is that they learn, right? You know that. They change their behavior. They personalize themselves, right? Two questions you should be asking all the time. How do you know it's learning? And what does your input do to change that learning? Okay. You use some tool. Is it getting better? Does the spell corrector learn my misspellings as opposed to everybody else's? For example, you probably have words like this. I cannot for the life of me spell the word guarantee. I don't know why. I have a broken neuron somewhere. I always spell correct it. Right? Does Microsoft Word learn that? No, it doesn't. But people believe it does. Right? So in this case, I agree the left one is probably the better one because it's all about getting the onboarding phase correct. And that's where you establish the mental model. It starts at the very beginning. So here's another kind of UI. What about this? Search the way you talk. The advice here, if you want to use this music playing app, is you can just search by saying things like nostalgic songs from the 90s. Right? Question you should have. as skilled people in the art of UX for AI. The question you should have is, so is that really true? Can I really say anything? What about sentences that are filled with mistakes and backups, regressions? I really want to hear songs from no, not from the 50s, from the 40s, no, I don't want big band. Is that sentence parsable? How extensive does that work? So, for example, suppose I use this and I say, deep cuts from Jimmy Buffett without playing the song Margaritaville. Will that work or no? Well, you can see the answer there. Didn't work out so well, right? So that advice is terrible advice. No, you cannot say just anything your heart desires, because it's going to key in on the high salience term and amplify that. So instead of giving me Jimmy Buffett songs without Margaritaville, it gave me all of Margaritaville. It's not what I asked for. Okay, so let's spend, it says 10 minutes, I'm gonna give you 5 minutes because we need to get to the next lecture. Let's think for just a couple of minutes about how to sketch a design for messages for an app. Let's do the music app that will encourage spoken commands. Because I don't know about you, but mostly I type stuff. I use my thumbs to type to my music app. How can we encourage you to speak to the device? And how can you tell when the system has an error in it? It says mapping error here, but let's do the music app. Okay. Let's talk about then why you would choose one design over another. Go, you've got 4.5 minutes because I wasted 30 seconds. Okay. Chat with your partner while I look for the bell. Yeah. I just don't think it's fair. So it goes. Yeah, that's very possible. Okay, everybody. I'm really sorry about the bell. I would love to have the bell back. So if one of you took it, please return it, no questions asked. Second big point, one of the things that will come up in this class is at the end, the final project, you'll be doing it in a team. So it behooves you to get to know your classmates. At least get to know them on a hi, I know your name basis. So heuristic for you, sit in a different place every day because you're going to be forced to meet new people because we've got little discussions in all of our classes. Okay. Anybody have a good idea how to encourage spoken interaction? What would you say?
I think I would ask.
Wait. Let me see. What's your name?
I'm Jackson.
Jackson. Okay, great.
I would think I would have some sort of either character or person
Cool.
users interacting with. Like I think Spotify has a DJX or something.
Right.
And you make a query. So it's it's more like an actual human interaction instead of just saying things into a text box.
So do you talk to DJX?
I have music. So.
Oh, okay. Okay, fine. Yeah. Okay, great. Anybody else? What would you say?
I would actually go the other extreme, which is to not even anthropomorphize it and just like a very simple instructions, like say skip with next, right? So I think it's trying to manage the expectation and just not make it as
I like this idea.
as simple as the legacy systems.
Right.
Yeah.
Okay, so I could say fast forward or skip or go back or repeat or whatever. Right. So simple commands that you show up in like a pop-up or a warm start or something. Okay. Cool. Yeah.
Very similar to that one. I would say more like if user wants to skip, you can almost predict that they might want to skip the button and have it a tooltip of like instead of pressing use command skip. So it's like as they may want to do that behavior, letting them know that there's a command voice that can do that.
Okay, that's actually a great idea. So basically giving hints as you move through the UI. Yes.
Just playing on features or features that we already are familiar with, like Hey Siri. We all know that when you say, like, with Siri, you're down here typing something and you're always saying, Hey Siri, and she knows that whatever. They know kind of the search that, I guess like Hey Siri affords for you to use your voice. And so I feel like having a system similar to that when it comes to Spotify, Apple Music,
Right.
actually allows for people to, like, or force them to use their voice as opposed to typing something in.
Very good. Very good. Okay, last one. Yeah.
We talked about maybe just getting rid of the text box.
Oh, get rid of the text box. You're a radical. Yeah.
Like, if you don't want people to, like, I think text boxes are associated.
I see. Oh, so you see the output, but not, you don't give an affordance for the input. You give a big microphone button or something. Yeah. Okay. These are all great ideas. A couple, another comment.
Maybe done something kind of interesting where like gotten rid of text box, but there's this like thing that
Right.
from when you can tell it is registering your voice.
Right.
Without humanizing it.
Yeah, no, that the active microphone thing, that's absolutely crucial because we know if you don't have an active microphone, people stop talking very quickly. So that you very quickly learn it's a bad idea. One quick comment about Siri. I was baking bread last night, and I said, "Hey Siri, set a timer for 30 minutes." My bread got burned. Does anybody know why? Well, stupid Siri lost the timer, right? And that sometimes happens. We were doing an interview study, interviewing people about their use of calendars and reminders and so on. And one lawyer we interviewed said, I used Google Calendar to set a reminder for my court date, and I missed my court date with the judge. I will never use it again. So there are some high stakes things you cannot get wrong. And so you need to give confirmation, very clear. And basically, if for something that's high stakes like that, physical reconfirmation, I have to click the button, okay, that kind of thing. Don't just let it, like Siri does that kind of thing. The second thing about Siri, and I think this is true for Google as well, is this happened also yesterday. I set a reminder, blah, 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 and it was several hours in the future. I come back an hour later, said, hey, Siri, do I have any timers? And it says no. Oh man, that sucks. It lost my timer. You notice what I did? I said, set a reminder. And over here, I said, set a timer. Timers and reminders in the Apple ontology are not the same thing, right? So you have to you discriminate between alerts, timers, reminders, et cetera, et cetera. This is great. Thank you. I'm going to move on. And so the key thing I want you to take away from this discussion is that the point of these mental models is to set expectations. We'll talk what else mental models are good for, but they primarily are setting your expectation for normal interactions. So when you're designing the UX for your AI system, do not set unrealistic expectations. Test it, test it, test it. If your AI can't really do it, don't advertise it. This is a huge problem in the industry right now. So this is basically what some of the ideas from the suggestion point. Use simple spoken command. Giving abstract, advertising, saying you're a virtual trainer, not so great. So I'm going to quickly move through this. So what would you do to make a content like this more understandable? So here's an AI backend for a design system. Pops up an error dialog box that says your content wasn't generated because your prompt includes wording that may be in violation of the designer code of conduct. I don't know what the hell that is. What is the designer code of conduct? Can I ask, what is the designer code of conduct? Because there's no actionable information here. Without me going off and doing research and hopefully finding the designer code of conduct. You see my point? I hope you understand what this all has to do with humans, right? We're building AI systems, but I'm putting you in the role of UX designer, researcher, PM, whatever, are responsible for making sure these things are understandable. So how much does having AI matter? Half of me wants to say, not at all. Not at all. Because truthfully, your users don't care what the technology is. It could be little tiny green mice from Lithuania in there making stuff happen. Users don't care. But AI has this special power, this special ways of working, special ways of failure, and we're going to talk about that in about 4 classes. The ways in which AI fails and what we have to do to make these things better. We're going to skip, we did that already. So now, good. I'm going to skip over to today's, there we are. Took a while. So today we're going to talk about designing AI, taking into account everything we know about cognitive psychology and so on. But first, AI news of the day. This happened, I think, last week. This is San Bruno. A Waymo vehicle made an illegal illegal U-turn in front of a DUI checkpoint. So the cops go over and say, "Hey, what? There's nobody in the car, right?" What do they do? Well, not surprisingly, Waymo has thought about this. So in San Francisco and in the peninsula now, and in other places where Waymo runs, they talk to the cops and say, "Look, if you find a Waymo car doing something illegal, here's the phone number to call. We will help you out." And so they all know this. And so it's a great picture, but he knows what to do. He's just checking to make sure there's no riders in the car. So they call the magic phone number. The magic phone number, a human picks up and takes over control of the car, and they get out of the jam. Waymo doesn't get a ticket, but they fix their programming so it not happen next time. So that's just a sort of a funny thing that happened last week. More seriously, this also happened this week. Senators in the Congress are starting to call for investigation of Tesla's full self-driving mode. So if you have I'm going to say this multiple times in this class. If you have a Tesla with full self-driving mode, I recommend not using it for a lot of reasons, not the least of which is if you watch the video associated with this, multiple Tesla drivers say, it didn't stop for the train crossing, even with the arm coming down. So that's how that Tesla got there. So, caution. In a few weeks, though, we will have a guy from Waymo talking about the issues and problems with building a self-driving car. And I will say why Tesla is not doing a good job of it. But it's interesting. He actually has facts and figures and data. Super interesting conversation. So don't miss that class. And because I wanted to have a happy note rather than just AI driving into things, there's been some interesting updates on ornithology through AI, which I didn't expect to talk about. But it turns out that a lot of the AI mechanisms for improving visual processing apply to radar tracks. And so they've been able to track 745 million birds in flight as they migrate from Canada down to Mexico or wherever they're going, right? So this was originally used to track clouds and rain. Turns out birds kind of look like rain from a distance. And so if you write the right algorithm to discriminate between tiny little raindrops and tiny little hummingbirds, you can track hummingbirds. This is awesome. If you're interested in that, click on that thing, you'll find it. Assignment number 1. Okay, how do people do? Is okay? Any issues? Okay. Great. Oh, I need to go over here. Oh, not to that. Spreadsheet. There we go. So this is the spreadsheet summary that everybody put in, looking at the products. And so I sort of sorted here. And what I did, so these are all the answers you put in. And over here in column D, I said, give me the summary of this thing in one word, basically for cataloging purposes, so I can then sort and do it. But interestingly, It didn't finish for some obscure reason. I don't know why. I can go through and click these one at a time and make them work manually. I have a large enough budget, so I didn't run out of tokens or whatever. Who knows? Anyway, it's super interesting to see. Several people spelled ChatGPT, just so you know, it's with a P. Lot of ChatGPT in here, but the range of answers is really interesting. Like providing feedback on cover letters, explain a lemma I didn't understand in math. This is all awesome stuff. And we'll get out of ChatGPT here. We get to Cursor. A couple people using Cursor for different reasons. What I found interesting, and what I encourage you to go look at the spreadsheet is to find other things that you don't know anything about, like DeepL. Not a lot of people used it. Deep Sky, fantasy football. Good on you. Facetune. So there are a bunch of interesting different things. There's different kinds of apps, lots of things like that you expect. Things like Lovable, which I'd heard about but never actually seen. It's interesting. Just I'm sharing this with you to let you know about the range of different kinds of AI systems that your colleagues are using. Okay. There we go. So there were a lot of things like this. And one of the things about remember the positive transfer thing? So now this is answers about AI positive transfer. So ChatGPT, Claude, all of the LLMs work in kind of similar ways, and the UIs are very similar, which is great. Somebody here points out that Maps has a very, very similar kinds of UI. Again, slightly different use models and detail, but it's all good. It's great to hear that sort of thing. Okay, now what I'd like to do is to talk about one other thing real quick. Let me pop back to here. It's hard to type standing up, let me tell you. What I'm looking for is docs. No, I'm just going to go to syllabus. Here we go. So a couple of things about the syllabus. If you notice, I might have mentioned, I think last week, that I'm putting in these extra events. These extra events, like on Friday, Bjorn Hartman spoke about code generation. Anybody go to that? There we go. Okay. Well, if you didn't go to that, maybe you should go to, or think about going to this one coming up this Friday, 11:30, just over at Gates. This is going to be Xingyao Li, who's here in Stanford, talking about the sort of history of speech recognition. And I hope to make it over to that. That should be a really interesting talk. So we have these HCIAI seminars every Friday. So the other one thing I want to point out is this. I just added this today. This is an overview of these several lectures. So if you're getting lost in this whole morass of content, here's the way to think about it. So we've got, this was Thursdays, and I just finished this up, mental model stuff. This is today's, designing AI with taking into account all of this stuff. And then Thursdays, mental model AI, okay? So that's a kind of a quick overview. I'm not gonna go in detail, but let you look at it later at your leisure, okay? So this is where we're at. We're designing AI with psychology, taking that into account. More about mental models on Thursday. You might think we can be done with mental models, but no, we're not. We're going to talk about mental models forever. And then on next week, we'll start talking about ethics, okay? Good. So now let's go to, this is what we'll talk about today for the next hour. Talk about the definition of intelligence and so on. And I'm going to go way back in 1904. I was not alive then, but they tell me that there was a very interesting, very smart horse that was touring Central Europe in 1904. And it was a remarkable horse. It could do math questions. You would say, Hans, the horse's name was Hans. Hans, what's 2 + 5? And it would wrap it out with its hoof, right? Or it would say, who is the mayor of this town? And he would walk over and nudge the person who's the mayor of the town. Question is, how does it know? How does it know? This case turns out to be important in the history of psychology because what clever hands figured out wasn't how to do math, wasn't how to do person identification, none of that stuff. It was responding to the subliminal cues of its trainer. So what this told people, the psychologists at the time, is that there are these very tiny things that people do that if you could pay attention to them, actually signal all kinds of interesting information. Looks intelligent. You probably know the story about Mechanical Turk. I don't need to go over that again. It's all kinds of stories like this. But the trainer was doing all these sort of very tiny motions as part of the communicative act between horse and trainer. So this led this notion of observer expectancy effect. Why am I telling you this? Because we see the same thing in AI systems today. Observers, people who use the AI, expect a lot from it, and they see it. We could talk at length about the expected religiosity, the expected spiritualism of AI systems. And people, no surprise, see it. So this is going on all the time. Now, we're going to talk about a system called ELIZA in more detail later, but I want to tell you about it. I'll tell you about it multiple times because in 1968, all right, Joseph Weizenbaum wrote this program called ELIZA, which simulated a Rogerian psychotherapist. And what he did in building this very early AI system was to have a chatbot that would talk to you about your life. And it totally worked. It got people sucked into it. And so when I was first teaching AI back in the early 90s, I assigned the ELIZA program. I would have said to you, okay, students, here's how ELIZA works. And I can draw for you in like 10 minutes, the whole architecture, how the code works, blah, blah, blah. Go ahead, implement it, right? And you would do that. And then I would say, turn in some transcript of the conversation you had with the system you built. Unfailingly, people would turn in transcripts that were 20, 30, 40 pages long. Like, I'm sorry, what are you doing? They would get totally sucked into the simulation of a caring conversation with a caring, concerned psychotherapist. I no longer assign this assignment because I learned way too much about my students. I learned all about the dramas of their love life, all of the dramas of their scholastic career, everything about their parents. And it's like, okay, A, take the takeaway. This works really well. B, this is a dumb program. C, my students built it. They knew the trick. They knew it was clever Hans inside the box. Didn't matter. In Joseph Weizenbaum's book, Computer Power and Human Reason, there's a story about he walked away one day and he comes back and his secretary, because that's in the days when people had secretaries, his secretary was engaged in long transcripts. And he walks into his office and she says, "Stop looking over my shoulder." Why? I'm in a conversation, a private conversation. Like, okay. You see the point? This is true of AI systems today. We will come back to this topic, but this is you can get this illusion very simply. So I want to talk to you about when you're designing AI, you're designing your future chatbot. Suppose, for example, that you are working as a researcher or a system engineer on a psychological health chatbot. What should you be thinking about? I'll tell you, one of the most common things that people say is that they should figure it out with ML. And I want to show this to you because, you know, Hans Solo is right. Machine learning does not solve all known problems. People think it does, and people will sell it to you. And there are companies with billion-dollar valuations that are based on this slide. Yes, we will. We will figure it out in machine learning. But that's not how it works. In particular, Here's the first heuristic I want you to remember. Will the AI address the user need in some unique and fundamental, helpful way? So you should be designing a system, whatever it is, not to be AI first, like so many companies are, not to be AI technology driven, but to be unique value add, whatever that is. Because I've lived through enough technology revolutions that I remember when people said, we are going to be an object-oriented first company. You see how well that worked out, right? There are no more object-first oriented companies, right? Et cetera, et cetera, et cetera. It's a little bit like whenever you hear someone say, we are technology X, where X is whatever, you should be very worried. We are a steam-powered first company. No, you are not a steam-powered first company. You are solving a different human problem. You are not vaulting the technology into the forefront. So we talked about this in the last one, right? This is one of those cases where people see it as AI. They think it's AI first. It's not. It's just a pattern match, very simple pattern match. Or this one here, this is spell correction totally helping me out here. Stanford with 3 A's. It says, yeah, no, I know what you mean. Let me help you out. So this really is AI stepping in and helping you do the right thing. So there's a very clear, for spell correction, a very clear value add, no question. Throw the AI in there, make it work. Now, second big design question, how do you work with an AI system? And I mean from the user perspective. How does the user work with an AI system? So here's an AI system, right? And they worked really hard on this. And I'm gonna let our speaker from Waymo tell you all about the details of this. The key thing I want you to notice here is it's very, very, very straightforward. Very simple. It's very task-oriented. They are not selling you their deep learning model. They are not trying to tell you how wonderful the technology is. We have Wi-Fi. It's irrelevant. What is relevant is that you've got a destination. It's very clear, a lot of branding with the Waymo thing, and you push the blue button to start the thing. Buckle your seatbelt. It actually won't move unless your seatbelt is buckled. So here's another question. So here is what I call AI incidental behavior. So as you're typing your query, you get up to the I-beam cursor right there, and it does autocomplete. Question, is that good or bad for the user? The people who say it might be bad is that it's channeling your normal expression into ways that the company wants. So in this case, Google is suggesting everything to the right of the red cursor. It thinks you're going to type techniques, but I haven't typed anything yet. In fact, these are all the other possible high frequency completions of that query. Note for you. Note, this is not the frequency sort of search completions. I've seen people write papers on this, taking that list as the high frequency completions for prefixes of searches. That's not true. This is a very highly filtered and modulated list. It's got all kinds of things removed, like, sexist, racist, offensive speech. That's all gone. So there are completions you can see, you can type that will not ever show up in the completions list here. So don't do that mistake. Anyway, the question to you is this a good idea or a bad idea? Because Bing doesn't do it. It doesn't put in the gray text up there. Which do you prefer and why? Leave that as a rhetorical question. But it's a choice. It's a UX choice in building your AI system. Do you autocomplete or not? So in this case, when do you want to use AI? Well, here we get the Copilot answer, which is their tie-in to ChatGPT, or their API to that, which gives you a set of summary answers to those ancient Roman construction techniques. And here's a different version. The difference, there are a couple differences here, one of which is the Copilot answer is kind of complete. Google gives you, and you can see more. So that's another design choice. Even the simplest tie-ins for AI have fundamental design choices you have to make. So you can see the differences here. How you choose how many pictures to put on the page and all that stuff, really important. Bing, Microsoft, has put a lot of photos, a lot of images on the page because they know people love pictures. They just love pictures. And if you just slap random pictures up there, we've done this, slap truly random pictures up there, people are like, yeah, that's awesome. The fact that they're irrelevant doesn't seem to bother people at all. If they're relevant, it's better, right? But that's why you see so many on the right. So let's look at a sample made-up AI system. Okay. So we could have automatic social emails. I'm not going to assign this, but you can imagine building this out. So it actually ties into your calendar. It says today's John's niece's birthday. John's having a really busy day. And so John's agent, his social agent, says, he doesn't really have time to wish her a happy birthday. So the agent could step up and say, hey, I will auto write a birthday message. Can you see someone doing this? I'm willing to bet $1 that there is currently an agent company out there selling this product. I don't know this. When I wrote this, it was all fictional. And it would automatically send it like this. The niece is happy. John is happy. What could go wrong? So has it ever been you've been so busy that it slipped your mind? Yes or no, right? This is the kind of survey question you would get. So hold on to that thought for a second, okay? We're going to come back to it. I want you to think about 4 key attributes of designing a user experience with an AI system. What problem does it solve? What unique value does it have? Is it sensitive to the user's value? Is it a high stakes or low stakes operation? Can people have accurate expectations about that? That is, can they build a reliable and predictable mental model about it? And finally, graceful failure. When things don't go right, can you have a way of knowing that and correcting for it? These are 4 key attributes when you're designing truly any system, but in particular for AI systems. So we're going to do a little problem-solving exercise here. So let's design with the AI in mind. Here's a sample problem statement where people get too much unwanted email. The logs show that people are uniform in the way they deal with it. They ignore it, delete it, blah, blah, blah. They do all this stuff. So is there some AI system we could do that would help to build this? So what you might do is make this little chart here. Here's solution 1 to user sensitivity, accurate expectation, right? All makes sense? And what I want you to do is to think about a product very much like the social email thing. You are the designer of a product called Flexible Snooze. And the Flexible Snooze lets you choose a time to wake up, but it also has a smart snooze mode, AI smart snooze. It will look at your work calendar and determine how much longer you can really sleep. Okay. It also has escalation mode where it can work harder and harder to try to wake you up. So the way it works is you set Flexible Snooze on your phone, creating a profile for each of your calendar entries. You do this once. You say, this meeting with my boss is critical. This meeting with my buddy Tobias, it's unimportant, right? And then I set my alarm, but I can say Flexible Snooze this guy, okay? So find your partner and discuss how you would fill out this chart here, right here. We give you 4 minutes to do this, okay? 5 minutes to do this. How would you do it? Rather, how would you fill out this chart? So what I'm going to look for is what goes in this box and why. Go. All right, everybody. All right. How many people got greens for the user sensitivity for not enough snooze time? Anything? What did people put upper left corner? Green, reds, yellows? Green. How many people got green? Okay. Oh, okay. Okay, that's a good question. What do we mean by user sensitivity? How sensitive is the user to this thing working or not working or making mistakes or so on? Does it meet their expectations? I should have said that up front. Okay. How many people would put green in the upper left corner? Anybody? Okay. What else? Reds? What would you put? So you guys are on the border.
I think we were just saying, like, if this doesn't go well, you miss like part of your day.
Yeah.
So we did see the two problems on the user sensitivity side.
Yeah.
As that different, I think where we had more, you know, variation between the solutions were accurate expectations.
Right. Great. Good. So you bring up a good point. Those accurate expectation and graceful failure, they're tied together. Because if you have a good understanding and accurate expectations for where this thing works, then you will understand how failure modes work. Right. Anybody else have a comment about any of this stuff? What's a graceful failure? Yeah. Yeah.
Your trust into to, and into something to determine what that's.
Right.
So you yourself never know when you're supposed to. Because it has some value that it's
Right.
really have to build trust in something like that.
Yep. Yep. So you bring up a really good point, how much you trust it to do the right thing. So this is how I filled it out. In my version of it, people figure out they're sensitive to it. They can explain it accurately, but accurate expectations for figuring out when to wake me up, setting the snooze time. I think that's a really hard problem. Trust is an important part of this. If you live with someone, you get all the sort of backstory of their life, and so Christy and I were talking about. If you mark something, an event as important, my meeting with my boss at 9 a.m. on Monday is really important. But over the next year, that degrades in importance. It becomes less important. And I can see you were up till 3 a.m. and I mark that as non-important. And so the flexible snooze changes the status. That might be okay, but there's no mechanism for doing that. How about graceful failure? Anybody have a good thought about how these things can fail gracefully? You got an AI system, it blows it. What do you do?
I was just gonna say the failure mode listed here where it's not absolute time, it's like.
Yeah.
Reasonable, like you just do it supposed to sleep.
Right.
You have to get earlier, with a blind maybe, but the other failure where you oversleep into a meeting.
Yeah.
Yeah. Definitely read.
Yep. All right. Yeah. So in my mind, graceful failure is basically when something goes wrong, I can understand why it went wrong and how to fix it. So this is all the mental model again. So I trust that it's not going to lose an event like Siri does for me. And when that's something like that happens, I can figure out. I've never been able to ask Siri, "Hey Siri, why did you forget my event? My bread is burned. You screwed it up." It has never once apologized to me. It has no idea what I'm talking about. So that model doesn't extend to that far. So user sensitivity is based on what we know about how people think about these things. How likely are people to think of this as an obvious thing, that they're sensitive to what it can do? Is it safe or is it scary? So for things like social interactions, you need to be very, very careful. Social interactions are difficult for AIs to understand, partly because a lot of the social interaction stuff, or for example, flexible snooze, depends on conversations with other people that don't get registered with the AI. So it doesn't know, has no idea. This is an important part of a lot of AI, is what does the AI know and what does it not know? A lot of people believe Google, Amazon, Microsoft, they know everything about you. No, not really, right? They don't know that I was out too late last night and I had a little too much to drink. No model for that, right? My friends were buying the drinks. It doesn't even show up on my credit card. So there's a lot that happens in your life that the systems can't know about, and that can be important. Dealing with financial stuff, same thing. These are all kind of high stakes, and you want to be very careful proceeding into design. Building up accurate expectations about these AI systems is important for designing these things. How can we portray the model of the system accurately? So at Google and all big companies, they have what are called UX writers. So has anybody done that job? You've been a UX writer? So what they are people who know how to write a little piece of prose to accurately communicate something to a wide audience. And it's a real skill. It's a real skill. Your PM might say, Dan, you've got 10 words. You need to indicate what the failure mode is. Like, right. So you need to then test it and actually work it out with people. So, for example, when you're setting up expectations, we talked about using an avatar, using a personification of an app in order to elicit particular behavior. Is that a good idea or a bad idea? Short answer, it depends. You're unfortunately going to hear that a lot, but it depends a lot. So graceful failure. What you want to do in graceful failure is to communicate that something has failed and how to recover from it. So what do you do to get it back to working again? This is a terrible response. Do not say 404 because you're not suggesting what the corrective action could be. So every AI system you build should have a way to register that something went wrong and communicate to the system what went wrong. And it should communicate back to you what the corrective action is. That's what a graceful failure is. So there's a lot of different aspects of this, and Peter was part of this, writing this book with Alfred Spector and folks. You need data, you need lots of different approaches, but basically the graceful failure is you need to do the analysis. What could cause things to go wrong? Including stuff that's not in your control. Including stuff that's not in your system. You need to do that kind of systems analysis to determine that. So when we design, I want you to keep in mind, we design for humans, for human qualities. We take into account things that lots of PMs hate. You have to think about what the emotional responses are. You have to be able to calibrate to people and consider the operating environment. For instance, designing a website is not particularly an AI thing, right? You can have AI systems help you with the websites. But here's a story. A friend of mine was running a website design shop in Switzerland. And they had a bank in Ghana come to them and say, hey, we would like you to design our website. You guys are the world-renowned experts in designing this. So they did their Swiss design things, beautiful, elegant. It's in muted shades of gray and very dark red. And it's beautiful Swiss design. They take it to the bank in Ghana, and the Ghanaians say, what? What's wrong with you? This is terrible. What happened? Complete cultural mismatch. Complete cultural mismatch. The Ghanaian bank wanted a much more vibrant color palette. They wanted things to be expressed in local terminology, not in Swiss language. I don't know if you've been to Switzerland much, but they have a very particular way of talking, and it's not that style you would see in Ghana. So there's a kind of emotional consideration, calibration, and thinking about the operating environment. This thing is going to run in Ghana. If you're building an AI system that's going to run in Ghana, I suggest you go to Ghana, right? Because you probably can't figure it out from here. These seem obvious, but in practice, a lot of this doesn't happen. So you want to be able to convey the value of this kind of thing. So make sure that people understand, even if they're skeptical, they need to understand the compelling value, and it needs to be transparent. By transparent, what I'm trying to portray here is that people can see where the data sources are coming from. The compelling value articulates why the AI is helping you out here, and the skepticism makes everything visible in the operation. So this matters because your mental model guides your behavior. What you know, what you believe about the operation of the AI system determines what you do. So remember the thermostat? We find that there are basically 3 different mental models in the world. There's the flow one, which is the dial controls how fast, how high the fire gets. So when you turn it up to 100 degrees, it heats up the room faster. That's not true. There's a second one, which is the thermostat is a timer. It goes on and off at specific set times. That's also not true. But the feedback model, where it turns on and off the heating element in a binary fashion, is actually correct. So you change the thermostat setting based on which of those mental models you have. Here's another example. I used to test people with this, and I said, hey, student, I want you to figure out what kind of fish this is. You go to Google, and ignoring the AI part of it, what would you do? What query would you write? What would you suggest? Just shout out an example. What's your Google query for this? Anybody? Yeah.
Black fish with red
Excellent. That is an excellent query, actually. Because what I've asked other people in various settings, I said, so how would you search for this? I had one person say, oh, fish, cranial hypertrophy. That is a terrible search query. A terrible search query because it's overthinking, it's over-technologizing the kind of response. And so you actually don't get any great results. Cranial hypertrophy is a thing for fish, but it doesn't get you the answer. Your query is much better. Right? So I said fish big bump on head, and that actually gives you exactly the right answer. So now mental models can be life and death kind of such things as well. So anybody remember the story about the 737 MAX? Anybody know that? Okay. So in short, it was a plane introduced by Boeing a few years ago that had a whole new automation system installed. And the idea was it would basically sense when the plane was about to stall and then change the elevator, the trim on the elevator, that thing there, the back of the plane, to basically get it out of the stall. So when the plane goes up too fast, it starts to stall, it pushes it back down. What could go wrong? It's a very simple AI system. So the system was called MCAS, M-C-A-S, and Boeing installed it. And one of their design goals was we need this to go into planes as a software update with no additional training required. Cost too much money to train people. So they updated the software, said you got this brand new plane, it's great, awesome. There you go, doesn't cost any additional money. So as you probably know, it really didn't work out that well. Several plane crashes, one in Jakarta, one in Ethiopia. Hundreds of people were killed. The problem is that if you get into this situation, you're flying this plane, A, you weren't told about this software update, right? No additional training required. So nobody told you. B, the interaction changed. So when it starts to stall out, you've got a couple different things you can do. You can change the trim, you can push the yoke forward. You do all these things. There's a manual trim wheel on the control column. It turns out that if you don't know how to override this thing, turn it off, you're going to fight with it. And so this is called automation surprise. Automation surprise happens when an automated system is doing stuff and you don't know why. It surprises you. So in this case, hundreds of people were killed because the pilots did not know how to override the system that they didn't know was there. If they had read the updates that were sent out to all the pilots, 200 and some odd pages of which, they would have known that. But like most people, pilots are very good, but they didn't read to the end of the chapter. And they didn't know that there was a switch to override the whole thing. So this is the curve of them trying to save this. The ultimate bug turned out to be that there's an angle of attack indicator, and there are two of them on most planes. In fact, the 737 has two of them. But this software update only took input from one. And if that one was wrong, the control system and the pilots would fight over control. And the plane won. The plane would win. So this is automation surprise, and it's not great. You don't want it to happen. I want to switch focus for just a second. Talk about, if you're going to design an AI system, you need to understand what kinds of capabilities you have. AI is more than just ChatGPT. It's more than just Gemini. It's more than just Copilot. So this is a partial list. There's a ton of different things one can do. I'm going to spend just a couple of minutes kind of giving you a little bit of the lay of the land so you can see what kinds of things you can do. So feature detection is an AI operation to try and find particular things in a data set. The most obvious one is trying to find faces. So for example, lots of cameras will focus on a face because there's an AI system in there to find the face. Some of them even detect when the eye is open or when they're smiling. You can set those options. Plus face, plus smiling, plus eyes open, right? So that's just feature detection. And we talked about that last week when we talked about during class. Then, of course, a more advanced version of that is cancer labeling, cancer detection in medical imagery. And there's a bunch of work that has been done on this, and it mostly works pretty well. So once you can identify things, you can start to identify lots of things. And then clustering is just what you think. It's putting things together that are similar. And that's what you saw in Google Drive. So in this case, it's actually doing a bunch of AI extrapolation. So I search for a presentation and here's a bunch and it will give me a whole pile of that stuff. Or you can cluster different kinds of images together. These are obvious images, but clustering them allows you to identify different versions of the same thing over multiple data sets. Sequence prediction is most obvious thing we see now in large language models. When we talk about that, they're basically sequence predictors. But you can also see it in things like the swipe text input tool. So here, gold is what the person is doing, red is the prediction. So you can see as the person swipes at every phase of the motion, the system is predicting where they're going to go. And that's how it works out what the word is. So classifying and labeling is another kind of AI category where here you've got an arbitrary scene and it runs a classifier over everything and tries to identify pieces of it. Each of these has a particular failure mode, right? So oftentimes they're undiscussed. So what's not labeled here? Most of the image. Doesn't label waves, doesn't label sand, doesn't label tree, doesn't label houses, doesn't label sky, you know. Okay. When you're designing with AI, you have to know what's possible and the inherent limits of all those things. So classifiers will not give you ultimate classifications of everything. So here's another version of Google Photos. Here I've asked for Katie at the Golden Gate Bridge. It's my daughter, and there's a bunch of pictures there. I showed you the cat illustration. If you search for calico cat, which I thought it would work because there's a lot of calico cats in that, all of a sudden it falls off the edge of competence and gives you nothing. This isn't a system push update. This is a failure of competence in the system. So when you're doing these kinds of analysis and engineering, you have to think about what can each of these systems do. So let's do a compare and contrast real quick. Here's a picture I took the other night. And I asked Gemini, what is this? And it says, oh, that's a Spanish colonial style mission, and it gave me a whole breakdown of the scene here. It went on to the second page where it says in the second page, oh, it's Mission Santa Clara, down in Santa Clara, not very far away. It actually told me where it was. I thought, that's kind of nice. What happens if I do this with ChatGPT? It says, oh, it's a mission style thing. At the end, it said, do you want me to try to figure out which one it is? Gemini just gave it to you. ChatGPT, well, maybe he wants it, right? And if I said yes, it will tell me and give me a sort of set of reasons why, which are not quite the same as Gemini's. So they have fundamental different kinds of capabilities. This is Claude, has no idea where it is, somewhere in California. Perplexity, even less. So the point is, each of these has a very different kind of capability space. When you're designing, when you're building, you need to understand it's not enough for you to just say, oh, AI. It's not just machine learning. Right? So we were going to spend 5 minutes doing this, but I'm not going to do this. This basically reiterates the point. What are the kinds of things that you need to know? What does this have to do with humans? Everything, right? We have to think about how these things interact with individuals and in communities. And I'm going to, I think, pick up with this topic when we start next time. And I want to get you to that. There we go. Go ahead and fill that out. And I know we ran just a little bit long today, but we will conclude this on Thursday with part 3 of our exploration of AI and psychology.